So now I want to talk about some real world applications. Where does this stuff come up? A bunch of nodes connected by lines. Well, all over the place. Social networking, I'll talk about. We'll also talk about things like mapping, Google Maps, directions, location, pathfinding, routing. When you request a web page, the actual response itself comes back in a bunch of different little packets all over the place across this massive network. Really, they're just used all over the place. But let's start by talking about social networking or just the internet in general. So this is a visualization I found on Flickr. There's many of these out there, but this was one of the only ones I found that had a license that allowed me to use it. And I think this was somebody who, Ken CF, I think was their name, modeled, I don't know if it was Facebook or what social network, their connections between their friends. I think it was Facebook. And so each dot on here, each little node is a person, like Kimra L. And then you can see all the connections that Kimra has to other friends. And what's interesting here is that we can see there are these clusters. There's some people that this person knows who maybe don't know any of his other friends or her other friends. Like this Susan E. Maybe they met on a cruise somewhere or he was traveling. But then there's this giant cluster and maybe they went to school together, all these people, or maybe they live in the same city and they went to college. There's, different groups here. But this is a way of representing a social network. So Facebook, Instagram, Twitter, all of these, they're storing your friendships, your relationships, and much, much more than just a name like we have here. But that's the bare minimum, really, to represent the structure of a friend network, of an actual real-world social network. Or think of storing actors and their relationships in movies. And, the different actors that have been in each movie, you could store it this way. Here is a visualization of part of Wikipedia. These are pages that link to one another. And this is just a small subset of it. There are way more Wikipedia pages than the nodes that you see here. But we can see there are certain clusters, and like for this one here, whatever this is, it links to a ton of different pages that themselves don't really link to other pages. And this is just Wikipedia, but the web itself, the internet in its entirety, we could model as a graph where we have web pages that link to another page. So anytime that one web page links to another, that would be a connection from one node to another. Here's another application. When we talk about mapping, this is a really, really common one. When we think of how Google Maps, for example, or MapQuest, if you were back and you remember that, printing out directions, I used to have to do that for my parents. When you think about how you would store that, a map itself in roads, let's just only talk about roads, not hiking trails, not bike lanes. There's a bunch of nodes, different cities, different locations, waypoints, restaurants, whatever we're talking about, and then roads that connect them. And those roads are basically the connections that we talked about between the nodes. And in this example, this is in Guatemala, to go from this one city, beautiful city, Antigua, to get to Lake Atitlan, which is a beautiful lake. There are many, many options. This is only showing kind of the two fastest. But of course, we could go some ridiculous route, like go through here, and then go over here, then go up this. And there's a bunch of ways to get there. And Google Maps is basically calculating the fastest way to get there along this graph, where there are many different options. And there's many algorithms that talk about finding that shortest path and what's the easiest way to do that. And it's much more complicated than just the length of the road. There's things like the speed limit of the road, for example. You might have a much shorter road, but it's windier, or it's a dirt road. You might have traffic that Google obviously takes that into account. Things might be closed. So it's a lot more complicated than just calculating the shortest path. But my point is more that we can store this data using a graph. It's a bunch of nodes connected by roads. So recommendation engines, that's another one. When we talk about anytime you see something on a website, people also watched, like on Netflix or Hulu. You might also like X when you're listening to something on Spotify, for example. People you might know, Facebook or Instagram or Twitter, they all suggest those. This thing was frequently bought with on Amazon, for example, and many other web pages. Those are all recommendations that are made to you, and often the way that they're made, the way all this data is stored, is in some sort of graph relationship. So here's a super simple example I made with 2 video games. Imagine that we had this for every single video game ever made, and I didn't actually write out all the data points, but here's a graph for the game Halo and for Borderlands. If you're not familiar with the games, it doesn't matter, but what you can see here, the ones in green, I didn't actually write text for all of them, but the things in green, they are nodes that both of these games have in common. So these are like genre elements maybe. Space, future, sci-fi, guns, first-person shooters. But now imagine that you have this expanded not only to include every game in Amazon, for example, or in Steam or whatever app you use to buy a game, but also other things besides just genres. How about user reviews and clicks? People who clicked on Borderlands also looked and browsed what else? Or trailer views. There's so many different things that you would take into account. And then to suggest something, let's say I bought Borderlands and I finished it, to have a little box pop up and say people also looked at X, you might just look, you write code to figure out what games have the most in common, which ones share the most nodes. Okay, well in our graph it's only Halo, so we'll suggest Halo. So the data sets get way more complicated, but anytime we're talking about this sort of X also did this, or you might like this, or you should buy this, I guess that's a little more forceful, you should buy, but you might want this, those are recommendations pretty much always stored with some sort of graph structure. I forgot I had a little diagram there. The things in common in that box. Here's a cool graph structure that models all the different genres, or most of the genres, in music around the world. So if we zoom in, you'll actually see all of these connections appear. It's pretty crazy. So this purple, let's see, which one are you? That purple is Jamaican / reggae. And if we go, and unfortunately the zoom is kind of annoying, but if I zoom in, you can see, all right, so there's dub, and then we hover over dub and you can see all of its connections to other nodes. For example, it connects to old school rap pioneers. Or if we look at deep funk and new funk, it has some connections over to freestyle and breakdance on the right in red, or to early funk and P-funk. And anyway, this is a fun website to check out, but this is a graph structure at its core, modeling the relationships between genres. This one also has an added dimension, though, of time, I believe, as things developed. You can see that, let's see, down here are the more recent trends. Up top are the older types of music. So you can see like classical is over here. And what is this? Folk music is here. Anyway, so graphs are really commonly used. They're sort of exciting, I think, to know about. And the next thing we need to do, now that we've established the base definition, it's a bunch of nodes with connections between them, and there's not a pattern like there is for a tree or for a linked list. There's sort of free form, and it's just nodes with connections. What we need to do next is talk about different types of graphs and also a little terminology so that we understand the type that we are going to implement, which we're going to get to very shortly. That's coming up.